Hello and welcome to today's panel discussion, AI inspection techniques and who will be the Google of the production line. Every pick and place manufacturer and every provider of inspection equipment has an offering of their own software solution to extract data from the production line for predictive testing and to provide full traceability up to the MES system. This panel will discuss who is best placed to hold the mantle of Google of the production line. I'm delighted to be joined by three very experienced panelists. To my extreme left, we have Gadi Make from Arch Systems. Welcome. To his right, we have Karsten Sulewski from Viscom. And to my immediate left, we have Harold Eppinger from Co-Young. So welcome, gentlemen. Thank you for joining me today. I'm going to start with the first rather provocative question, and I'll start with you, Gadi. That is, who has ultimate control of the process? Is it the inspection systems or is it the MES system?
That's a combined answer, actually. It actually depends, on the end customer, what tool it's using. If I divide it, and I would say MES system is giving you the aspect and the view of the product itself. So you can see the product in the history and see the trend, what is happening within the product. The inspection system will give you the locally right now, what is happening, how many defects, but then you don't see the overall product trends and what is happening in the quality in the product. Again, there are combinations. There are systems that provide quality system, and they are not an inspection system that can provide you an overview of that with insights about what are the inputs for those failures. So it's a combination, I would say.
Okay. Would you concur with that, Carsten?
Yeah, I think the MES system might be a little late for some of the answers that you need. So with today's technology, it's possible to have AI server on the inspection machine and doing interesting stuff right now that's maybe not possible with traditional ways of doing the computing. But overall, I think the AOI and AXI systems, they gather the data and provide it to any MES system, and there you can do detailed analysis of your production process. So I think it's a good combination.
No, I think it's not a question of who can do it. I think it's a matter of, first of all, the real-time aspect and the amount of data to be executed. And I think I would say it's a mixture of pre-processing the data to be more efficient, because not everybody is interested on everything. So we have to focus on the different tasks, not losing the focus on the big picture. So I think there's a mixture of both.
So you think that the balance is likely to change with the increased use of AI?
AI is the common word and everything. Everybody believes that AI will save the world, but the problem is that it has to process data, and that is process know-how, and process know-how is still linked to people. It will change, but it helps to do it more fast, more quick, and being able to deal with this amount of data. I think that's the key.
Right. Yeah. No, definitely. I mean, but I think, just to diverge for a minute, the whole debate around AI is quite interesting. I mean, and how to be able to have a human decision at the end of it. I mean, I think the EU is about to come out with some guidelines on how to develop AI applications. Do you think that's going to be helpful, Gedi?
Yeah, definitely. I have some years in the SMT area, so going back the years as an engineer in the line. So you get the board after the OI, you see different defects, and you are doing like reverse engineering. What is the source of those defects? Looking into the BOM, they are coming from the same place. Analytics, actually, what is the root cause of the system? AI will actually help generate that. You will not be dependent on an expert. You will depend on the machine that doing those correlations and handing you what's the possible solution or the root cause, not the solution, but at least the root cause.
Yeah. Okay. So, Carsten, as we further automate the line, how important is it to include post-placement AOI? I mean, at the moment, up to now, it's been quite a hard sell. Most people go for certainly SPI and definitely post-reflow, but trying to get that post-placement.
Post-placement AOI had its reason like for many years. I mean, that was one thing is you can exactly measure a component position and feed it back to the assembly system and just correct for any whatever nozzle problems or whatever you have. In practically, I think many assembly systems, pick-and-place systems, can correct for that themselves. So you don't need a post-placement AOI to do that in general. There are exceptions. Then one thing is, in the whole thing of sustainability, you don't want to add waste to additional waste to the production. So what do you do with a borderline misplacement of a component? We all know that in the reflow process, some things will correct for itself. So even if it's overprinted and something like that, after the reflow process, a lot of these misplacements realign themselves.
Yeah.
So in my opinion, post-reflow AOI is a better way to inspect it. And it might also be more sustainable than just produce a lot of waste pre-reflow.
Well, it's certainly the last opportunity to correct it before you've soldered the component to the board and you're into a lot of money. But trying to get that message across and how effective it'll be. But as you said, some of these pick-and-place systems have it built in. I see you shaking your head there.
As an equipment supplier, we agree. Of course, you need a post-placement system everywhere.
I would like to start with your comment. You said it's hard to sell, and it was hard to sell because there was no benefit of a pre-reflow AOI, as long we discussed about inspection system and gatekeeping. Today, precise measurement is the key. We're all talking about precise and certified measurement systems. So the result helps to predict the process and to control the process. If we look into the history, yes, the components have been big enough to adjust. We are talking currently about the next generation of component sizes, and you need to apply certain control steps to secure the process. So I would say pre-reflow becomes more value since the data are proper executed. So before it was a gatekeeping and waste. I don't agree that this is producing more waste. I'm predicting that the process quality, the board quality, and the bandwidth of a process deviation is much, much smaller with pre-reflow. Can you afford it? It's a decision on the product and the product value. But we see an increased demand on pre-reflow for a lot of things, shields, combination, X-ray, processes, material, but we see much easier selling than over the last years for pre-reflow. So there is a need and there is a benefit, depends on the product. Yeah, that's clear.
Okay. If I can add on that, I think that the pre-reflow AOI results are excellent for calibrating the machine. You can drill down up to the head and specific part of the line that it's added value for later on. I mean, for sure, AOI adjusts the reflow adjusts itself the placement. That's why you cannot rely on the pre. The pre-reflow will be an excellent tool using AI to actually maybe calibrate and save a lot of time.
As I said, it always had its place in the line, but not in every case. It's what's needed. But of course, as equipment suppliers, we have these installations, and measurement is certainly something that's very important.
Okay. My next question. We'll start with you, Harold. I mean, the inspection or AOI inspection largely comprises cameras, lighting, and software. Camera technology. I mean, has it got to its limits, or has it still got a long way to go?
Every time when there's a limit, there's somebody who has a good idea and go for the next level. If you reconsider that, if you look to the resolution 4K, a few years ago we have been talking about 640, 480 resolution for nice cameras. Then we go for 1 megapixel, 2 megapixel. I think the latest technology is still
evolving,
still going forward. And is it the end? I don't know, but. Right. I can't believe that there is no innovation anymore.
Okay, so you think it's got its own mini Moore's law where it keeps getting better?
That's probably one point where we agree, right?
I think it's more what we agree. Yeah.
There might be more points too, but no, I mean, if we look at today's CMOS chips with 25 megapixel, 100 frames per second, that's plenty. That's good for today, but 5 years from now, we'll have more.
And I think there's one important thing. It's not the resolution; it's the data processing behind.
Right.
Because even if you create a 100 megapixel camera, there's a lot of data to be processed. So it's not just the camera, it's the environment around, and this is the limit. It's not really the camera.
And it's also what you're inspecting. I mean, these things are getting smaller, and which in itself is creating more data because you need stronger cameras and stronger systems to be able to see them. Okay.
So eventually, I agree. The speed is the key feature. You don't want the AI to become a bottleneck. And as you know, it's much component getting smaller. You want to be adjust, first of all, on the quality of what you're seeing and the speed process. Mm-hmm. Yeah, definitely agree.
Absolutely. Okay. So how can inspection systems assist with automating box build and final assembly? Now, the box build final assembly area has been very labor intensive and manual for many years, and there's various companies bringing in automation systems to at least be able to measure the geometric size of these assemblies, make sure the screws are in the right place and to the right torque and all this sort of thing. How much more can we automate that, and especially when you get into a high mix environment?
So from my point of view, it's a very interesting point to address. I think that it's not developed to the far extent of that. I mean, analytic in that part is crucial. I mean, we are talking about operators that don't need the working instruction for an operation they're doing every 5 seconds. You already know that. But sometimes it come a little bit, forget or, something happening, I don't know. So it's not in focus. So to analyze those data, how many defects they have on a specific component, this is important to understand what is happening in the product using those systems.
Mm-hmm. Yeah, we have a lot of X-ray systems installed in what we call in device inspection. Device inspection is a ready product, checking for absence, presence of all components in the finished product, but also in something that's very important, it's foreign materials. So if you have any extra screws, anything that's where it doesn't belong, especially in high-end consumer products or critical environments, very important, and we can detect that with X-ray. And we have a line that can even handle very heavy devices to make these inspections. So I think that's critical for high-end and critical area products.
Right. Do you do anything in that area?
Yes, we have part of the measurement tools built in the systems, but what we have to reconsider is the high integration, the miniaturization. Gives a small piece of electronics into bigger environment, and you have the pins, you have the mold, you have everything has to fit together. So suddenly this mechanical tolerance is becoming critical. So it's part of the SMT process in the end stage, but before the boxing is the final assembly, and all these mechanical deviations are root causing a bottleneck in the automation process. If it's not precise, it cannot be handled by machines.
Okay.
And I think that's the aspect we have to go for. Yeah, right. It will be some part.
Okay. So my final question is again rather what's the word? Controversial question. Some software companies say they want to eliminate inspection. I know we talked about this before we started, but we'll reiterate it. They say it's a wasted resource. What do you think about that?
If I would be a software company and I would not have a test system in the portfolio, that would be my marketing logic. But on the other hand, we have to say you need the sensors. We are not talking anymore about an AOI or an SBI. We are talking about sensor who takes data from the line, from the object, from the application. And I think utilizing these sensors doesn't matter if we as the vendor do it or any
Still has
uploaded.
To be done.
It has to be done, and the learning from this data will be the future. So it's not a question of talking about AOI, not you need a sensor. Without sensor, you cannot generate data. Otherwise, how you prove it?
Yeah, would you agree with that? I mean, the inspection machines are the eyes and ears on the line.
Yeah, you need the data, right,
Yeah.
to run whatever kind of models over it and detect anomalies. And I think there's a good future for inspection systems. It's optical or X-ray, because that's what's the eyes and ears of the production line.
Right. So Gary, we need the equipment, we need the sensors, the eyes and ears, as it were. Do we need does the data get crunched somewhere else?
Yeah, I will try to answer in a different approach. If you ask a quality guy from lean aspect, he would say quality doesn't have any added value, inspection on the process. You need to, but again, we are living within our world, so we understand. I think that, like you said, those give us a very good insight about what's happening in the process to actually provide some activities and understand the content. We talk about yesterday about event versus tag. If you are connecting those results to a larger story, you are able to get the root cause for that.
Right. Okay. Harold?
I really recommend that we should step away from the definition of inspection system. I think it goes the wrong way in the way of thinking.
What do you call it?
Line sensors.
Line
Because
sensors.
inspection has an old-fashioned style. It's gatekeeping, it's go, no-go, and it's not longer that world. It's changed. So when we still believe in inspection system, yes, you can get rid of inspection system, but you cannot get rid of the sensors at the line to get the information. And I think this will be the mixture of the change of phrasing will enable us to get a better understanding of what we need in the future and harmonized between software, hardware, and process know-how.
Right. I could see Carsten deep in thought there.
Yeah, I think current technology, allows different test gates and of course combines the data, and still there has to be a good bad decision, either based on the measurement data or based on other features that are important to say that's a good product, that's not a good product. And we didn't talk much about artificial intelligence in this environment. I mean, if you measure, you can't measure with artificial intelligence that way. You can use the data in an AI model and model something and maybe have a process indicator for something. But the good old-fashioned good-bad decision has to be done somewhere. And AI can help a lot with making this decision more safe. And I don't mean there's an advertising going on from one of the equipment suppliers. You're lying back in your sun chair, there's the beach, and the machine programs itself and does everything itself. No, the machine doesn't make the decision. There has to be a human interface somehow. And we use AI in programming, in segmentation, not in classification on the machine, but in post-classification, supporting the operator with additional resources, and that's what's happening. You can call that sensors and whoever, but a decision has to be made.
But is it really AI at this stage? I mean, it's still referring to essentially a database of information. Is it thinking for itself? I mean, because AI is artificial intelligence. It's thinking for itself. It's not. If it's referring to a database, then it's really deep learning. That's essentially what it is.
If you ask ChatGPT, it doesn't say it thinks for itself, and I think that's not the definition of AI at that point. It's a learning, deep learning, or neural networks that enable you to make decisions that are not deterministic. So every measurement, finding an edge, finding another edge, measuring the distance, that's a deterministic algorithm that can do that. If you give some input to an AI and get a result out of it, that's a different approach, and I think it is. So we actually compare it to human capabilities, and we see there are interpretations that are better than a human being is able to do it at the line.
Okay.
And that's something that's in the very beginning. And like the camera sensors, 5 years from now, we will see some big steps forward.
So here's a question. I mean, does AI really start out as deep learning, and it then amasses more and more data and more information, and at some point becomes capable of making its own determinations?
I think, it's deep learning, as you say. We are in the stage of deep learning. Metadata, understanding what we have, A plus B equals C, and the system understands A plus B plus D is E. So it's learning those with the human interface and evaluating that's really, really fast. You don't need a human being to do that because you already figured out the mechanism and the algorithm. So we are, as I believe, in the deep learning right now. As you said, I agree with you. But the stage is understanding this data and building the algorithm within it.
Interesting. Harold?
Yeah, I would say a lot of companies started to use AI or any other technology to get the noise out of the data. And we as vendors, we try to utilize first the AI technology to make the measurement more precise and more robust, which starts to reduce the amount of noise in the data at the end. So there's a lot of different technology altogether will be like a puzzle and will help us. But I believe there is still a lot of process know-how currently necessary because it's two dynamic parameters in the production line which are not controlled 100%. And it will take a while.
Yeah. Right. Well, on that, I think we all agree. This is going to be an ongoing debate for many years to come. But for the meantime, guys, I really want to thank you for your input today. I want to thank Gary Make from Arch Systems, Carsten Saluski from Viscom, and Harold Eppinger here from Co Young. So thank you, gentlemen, for coming in today, and thank you to our audience for watching.